What's the relationship between all three of these variables? We're going to start with wavelength and frequency, and we'll use this equation right here, c equals lambda f. So c is the speed by which light propagates, or travels forward, and it's equal to the product of our wavelength and frequency. This propagation speed is literally also the speed of light, because this is light that we're modeling. 2.998 times 10 to the 8 meters per second. In other words, because the speed of light is always the same thing, it's what's called a constant. Because the product of wavelength and frequency is equal to the same thing every time, that tells us something very profound about their relationship. Whenever one term is big, the other must be small, and vice versa, to ensure that the product of these two terms always stays the same. Think of it as a scale that we need to balance in order to keep each platform the same weight. This side is the only side we can manipulate, but if we do, we need to ensure that that side overall stays the same. This relationship is what's called inversely proportional, and it can be symbolized by this Greek letter homeolos. So we can read this as wavelength is proportional to the inverse of frequency. Just by looking at this equation right here, we can infer three equivalent statements. What about wavelength versus period? As a reminder, this is propagation speed, this is wavelength, and this is frequency. But hold on a second, where is period? Well, officially there's no equation that relates wavelength and period directly, so we're gonna have to derive the equation ourselves. We're gonna use these two equations. The fact that frequency shows up in both of these equations means that we can combine them together. We've used what's called substitution to marry both wavelength and period into the same equation. More succinctly, c equals wavelength divided by period. We've established earlier that c is a constant, so whatever it equals is the same thing every time. All of these quotients are equivalent to each other, and as you can see, both terms get big together and they both get small together. These terms are directly proportional to each other, symbolized by this expression, because as one term increases, so does the other, and when one term decreases, so does the other. My question for you then, and please put your answer in the comment section, what about frequency versus period? Now, if you look back in the video, or if you've been taking notes, or you've been paying attention really well, the answer is in the video.